like to talk about how you can do that with a system called Kafka. We do it with for our online media data. Here's a short overview. First, I would like to talk a bit about what is streaming data. Then a short overview about Kafka, then the Kafka architecture, and then the use case for which we use Kafka is the prospective search. Okay, what is streaming data? As we have heard, all web or all big companies collecting data. Web systems nowadays produce a huge amount of data, like log analysis, server data, as well as Georg said. And this data is getting more and more important. They are used for recommendation engines. They train their data, or they train the model with this data. They use it for monitoring. They use it for reporting. So this data getting more and more important. And what it actually is, streaming data is a part of website activity data, like I said, user activities like tracking data, the click paths of the user, and also the server activity like log files from Apache or something like this. That's all called website activity data, and that's one part of it. Then also social media data, or kind of streaming data, news data as well. So that's a huge amount of data, and it's getting very difficult to analyze this data in real time. I mean, you can do it in batch, the old fashion, but that takes time. That's called the offline part. So you can analyze this data with MapReduce jobs, but these jobs can take minutes or even hours until you get a result. It's not very suitable for ad hoc queries. So this gap closes Kafka, for example. You can use Kafka for real-time processing. So why Kafka? Kafka was originally created by LinkedIn and was contributed to Apache in 2011, and it's now in the incubating status. And it's written in Scala, so it runs on a Java virtual machine. The pain LinkedIn has was to solve their to replace their analytical platform, which was batch-oriented real-time system. They needed it, for example, recommendations of people you may know, for jobs you may like. They do all the kind of stuff with Kafka nowadays. So they feed their language models, as Georg said, or their clustering models or recommendation models, and do all that recommendation on your website. They're also the click path. They realize that the click path from a user is that way, and so they change their website. And now we can ask ourselves, why another messaging system? There are a lot of them available. For example, messaging systems like RabbitMQ or ActiveMQ are well established in the enterprise and are used as an enterprise service bus when you name it this way. And traditional enterprise messaging systems have a problem because they are not designed for log processing. They are not scalable, they are not horizontally scalable, they have a single machine. If that machine or that queuing system breaks down, the messages lost because they are all held in memory, for example. So it's not reliable, and as I said, has no persistence. Then there are other systems like aggregator systems, which are, for example, Flume from Cloudera or Scribe from Facebook, but they are designed for high throughput and scalability, but they are just for log aggregation as well. So they are quite simple systems, and they are just a push model. So the producer pushes a message to message broker, and the broker populates to all the consumers. But that's not very sufficient for real-time analytics, because you can have different consumers with different consumption profiles. That means you have a consumer which is real-time, that needs the data very fast. Then you have maybe an import consumer which runs just one time in a day, and so you have a different kind of consumers, and the aggregator systems are not used for that. So Kafka was built with high throughput and scalability in mind, and uses, unlike other messaging systems, the push-pull model. That means that the consumer pulls the data from the broker, and it says, I can read the message in my way. That means in my consumption profile, and there's no unread messages on the system, on the broker in that way. So we haven't benchmarked Kafka by ourselves, but Microsoft did a benchmark, which you can find on this source, and here is the consumption of the consumer performance, and you can see that Kafka can consume 22,000 messages per second on a constant rate, whereas ActiveMQ and RabbitMQ are not so good with this processing or consumption of messages. So let me now show you the architecture. Well, as I said, Kafka is a persistent public subscribe messaging system designed for high throughput. So let me explain every point in more detail. As I said, it's built as a classical messaging system with a broker as the central piece of the system. Then you have the producers on the left side, which are pushing the data to the broker, and then the consumers, which are pulling data out in their consumption profile, which can be different. So that's unlike the other systems, they use a push-pull model, as I said. Distribution is possible with the Zookeeper. As we all know, if we come to the distribution model, coordination gets very difficult and complex. So Kafka uses the well-known Zookeeper, which is also an Apache open source project for coordination and for leader election and all that stuff. So you can think of many more brokers here, which are all where the coordination is done by Zookeeper. And as I said, the design goal from LinkedIn was performance over features. Kafka is very, very simple and therefore much faster than other messaging systems where there are some complex transactional features which are not needed in that case. So that's all left out. Then, as I said, it's a publish subscribe system. So the conceptual thinking of that is that you can use topics, and topics are just a semantic way of collecting similar messages, or to collecting similar messages. For example, you can create a topic like logs, and the producer now writes all topic and all messages to this one topic. And the consumers can consume these topics, or many consumers can consume these topics. There is maybe no consumer for a topic, and there can be one consumer for a topic. So it doesn't, for Kafka, it doesn't matter if the message is consumed or not. Well, that's interesting because most messaging systems are not primarily persistent. Kafka is, as I said, and it persists all messages to disk. Well, now disk is slow. It's a normal way of thinking. Memory is much faster, right? But Kafka is very clever in this way, as it uses some very well ideas for writing the messages very fast to disk. Topic, as I said, is the base abstraction, and all messages which belong to one topic are written in one binary log file, which is like in Cassandra, like in HBase write-ahead log. It's a binary file, and the messages are just appended to the end of the file. So that's the way it does it. Then there are no message IDs in the system. Instead, there is a byte offset for each message, so you know when the new message starts from a byte ID, the byte position. Then the messages are retained a specific time in the system. That means the default is 7 days, and after that 7 days, Kafka throws away all the data. So Kafka is like an intermediate store. You cannot persist messages for a very long time. So just for the 7 days or whatever you specify, and then it throws away all the data. If you consumed it or not, it doesn't matter. Then how is the high throughput achieved? Well, as I said, Kafka is very simple. It has just it has a simple API, and it supports just two functions, like appending a message and reading a message from a given byte offset, byte position. Then it uses batching for high throughput, so the producer can batch messages. It can hold locally the messages until a certain threshold, and then batch it to the consumer, to the broker. Sorry. And the consumer can batch as well. He can say, okay, I need a message from this byte position, and my internal buffer is 500 kilobytes large, and I need 500 kilobytes of data. So the consumer, as I said, can consume the data in his consumption profile. Then the broker is stateless, so the broker doesn't know which data the consumer has read or not. It just knows I have a topic with the binary file, and I know I have to append all the messages at the end, but it doesn't know more. Then, as I said, due to the fact that an append file, you do not have to seek for a position, so you get a linear read and write access. And it uses under the hood a lot of Linux operating system features like page cache and send file and so on for providing the high throughput. Okay, that was a short wrap up about Kafka. Now I would like to explain you a bit our use case. And here we have a solution architecture where we have on the top left a lot of sources like feeds and blogs and social media and so on. And we have a bunch of news agents, which are nothing else than kind of specific crawlers which are scraping all the information from the web. Then the data is processed, enriched and so on, and then saved in HBase, and also written to Kafka. So the news agent is also kind of a Kafka producer. Then on the left side, the content which is saved to HBase goes also in Solr for search. And we have a web UI which you can access Solr directly per HTTP or HBase by REST API. And now let's go deeper into the solution for the real-time alerts where we use Kafka consumer, which you can see on top. There is a stream of articles which come into Kafka. Then the consumer just pulls the data from Kafka in a batch style. Then for each article, he does a prospective search. Prospective search means that it's different to a classical search architecture where you just index the queries and not the document, and then hit all the documents against the queries, and then you can see very fast which topic the document matches or not. In that way we can implement a real-time alert functionality for our system. Okay, that was all about Kafka. Here are some more resources. There is the quite well written project page from Kafka, and there's also a nice paper about Kafka and the usage at LinkedIn. Okay, that was it from my side. Are there any questions about Kafka or the usage? Yes?
Can you tell how Kafka compares with Storm, which seems to me like a pretty similar project by Twitter?
Oh, I don't know Storm very well, so I can't tell you the exact difference. I know it's also for real-time processing. It's from Twitter, but I don't know exactly the difference. Yes?
Can you give a message multiple topics, or then you have to write it in the... Yeah, you have to write it.
You have to write it in when you write, you can send a message to different topics. That's possible. Yes, but the consumer just reads from one topic.